welcome back, guys. First, I'd like to give credit to the author of this material. This material is from Jam Remix. Now we'll touch non-metal 2. This will comprise of chlorine and its compound, nitrogen and its compound, silicon and its compound, and also sulfur and its compound. So let's go straight into it. First question: when each of the nitrate of potassium, magnesium, and iron is heated, now you're left with what will happen. Now, if you've been following this series, on the previous series we talk about nitrates that decompose and those that do not decompose, and when they decompose, what's the product that are given. So what will happen is the nitrate of magnesium and iron will give oxide. The nitrates of magnesium and iron would give their oxide. This one wouldn't give an oxide. So number one is option C. It would give their oxide. Please, I would want us to write down NO2 equals nitrite. Now let me spell it for you: NITRITES, while NO3 equals nitrate, NITRATES. Okay. Number 2, hypochlorous acid is used as a bleach because right, hypochlorous acid is also known as oxochlorate 1 acid. Oxochlorate is spelled OXOCHLORATE 1 acid. This is formed when chlorine is dissolved in water. So when you dissolve chlorine inside water, you get hypochlorous acid. Some other students might be like, sir, is that why they call that stain remover hypo? Let's keep it there. But that stain remover, if you don't see hypo before, you go, if you check the back, you go see some of the content. It has chlorine inside of it. So I want us to write a chemical equation down. Right, Cl2, that's chlorine atom, Cl2 plus H2O equals HCl plus HOCl. Now that HOCl they call hypochlorous acid. Okay, next line, right, HOCl equals HCl plus O2. So that's the oxygen that is given out. So let's go to the question again. Number 2, hypochlorous acid is used as a bleach because it's an oxidizing agent. Don't forget, it's an oxidizing agent. So oxidation actually happens. Number 3, if chlorine gas is bubbled into water and then this yellowish green colored solution is exposed to bright sunlight for a while, what will happen? This question is similar to question 2. What will happen is that the solution will give out oxygen gas, leaving behind aqueous hydrochloric acid. Number 3 is option D. Let's move fast. Also, 4, the solution of a sample in a tube will be identified as chlorine if it gives. How do you test for chlorine? Right, test for chlorine. First, acidification with HNO3. This prevents precipitation of other salts. Next line, right, the white precipitate that's gotten is AgCl, which is soluble in aqueous ammonia. So if we come here now, we should be able to pick something. They say a white precipitate when acidified with dilute HNO3 and then silver nitrate solution is added. Number 4 is option C. Now go down and while your notes, write this also. Pb open bracket NO3 close bracket 2 can be used in place of silver nitrate. See silver nitrate there, AgNO3 can be used in place of silver nitrate. Then right, continue. But the white precipitate PbCl2 will dissolve on heating and reappears on cooling. Note, PbCl2 is soluble when hot and insoluble when cold. It's soluble when hot and insoluble when cold. So if the same way you test for chlorine, you could use silver nitrate or lead nitrate. You get then the white precipitate. So number 4, the test for chlorine, option C here. Let's move on to question 5. Okay, question 5. They say chlorine, bromine, and iodine resemble each other in that, first things first, you need to write chlorine, bromine, and iodine are part of same. They are right. Chlorine, bromine, and iodine they belong to the same group in the periodic table. They belong to the same group in the periodic table, and hence they possess same valence electron, same valence or similar valence electron. And since that happened, the correct answer to number 5 is that they will displace each other from a solution. So here's how it happened. Chlorine, if you put if let me say like a bowl of, if you get a bowl of bromine, if you pour chlorine inside, chlorine go remove the chlorine. Now some other person will say, how will he remove it? Here's how it is. If we put bromine and let's say bromine and hydrogen together, hydrogen bromide is an acid also, you put it in a beaker. If you pour chlorine inside, chlorine would pursue the bromine from hydrogen. Him will now react with the hydrogen. You understand? So that's what they call displace. Now if you get hydrogen iodide, if you put hydrogen and iodine together, then they together, if you pour bromine go pursue iodine. So they both displace each other. Do you understand now? So number 5 is they displace each other from a solution of their salt. They displace each other from solution of their salt. Number 6, when dilute hydrochloric acid HCl is added to iron 2 sulfide, sulfide here is HFES, the gas evolved will, everybody write this equation down for me. 2HCl plus FES equals FeCl2 plus H2S. FeCl2 plus H2S. So the gas that is evolved now is it's hydrogen sulfide. So the equation here, they say when dilute HCl is added to iron sulfide, the gas evolved what will happen? The test for hydrogen sulfide, it would blacken lead acetate paper. So go to the next line and write hydrogen sulfide, open bracket, H2S, close bracket, blackens lead acetate paper. It blackens lead acetate paper. So number 6 is option C. You get, so whenever you react HCl and iron sulfide, you get H2S. H2S they call an hydrogen sulfide. The darkens lead acetate paper. Number 7, which of the following silver, let's take down to test for hydrogen sulfide, the gas turns lead acetate black. Note, we can also use lead 2 nitrate or lead nitrate. You could also use lead nitrate. It will also turn it black. So let's go to number 7. Which of the following silver halide is readily soluble in ammonium hydroxide? So first, what is silver halide? Silver halide, once you see halide, it means say the compound has either, right, halide equals chlorine, bromine, fluorine, iodine. You get? So when they say silver halide, they mean silver and either of those elements. So they say which of the following silver halide is readily soluble in ammonium hydroxide? Right. Silver bromide is parallelly soluble, silver iodide is not soluble. Silver iodide is written as AgI. Silver iodide is not soluble, while silver bromide is AgBr, is parallelly soluble. So they say which of the following halide is readily soluble in ammonium hydroxide? The correct answer is option C. So silver chloride is readily soluble. See all of them here. AgI is silver iodide, AgBr is silver bromide, AgCl is silver chloride, AgF is silver fluoride. You get? All of them here, they are halide. Don't forget what I say, be halide though. Good. Number 8, which of the following tests would confirm unequivocally that a solution X contains a sulfate ion? So first you need to know, how do you test for sulfate? If it gives with, then they stop there. If it gives what? Right for me. The precipitate barium sulfate is spelled BaSO4. The precipitate barium sulfate gives, so if you check, you will see here option E actually. See, barium chloride solution, a white precipitate insoluble in dilute HCl. You know, understand that, maybe. More take the notes first. It's simple. The precipitate barium sulfate. So if I will take the note say sulfate ion there's something, we'll get a precipitate that they call barium sulfate. So So write down for me. Barium sulfate BaSO4 plus 2H2 plus 2HCl would equals BaCl2 plus H2SO4. So but here they are talking about the ion of it. So you write, so we're having BaSO3 plus 2HCl would give you BaCl2 plus 2H plus 2H plus plus H2SO4 plus H2SO4. So what are we going to get? You react barium sulfate with hydrogen chloride, you get barium chloride and H2SO4. So let's go back and see. Barium chloride solution, comma, a white precipitate that is also insoluble in HCl. Do you get? If you check that equation where you go discover, say I said BaSO3 abi plus 2HCl would give you BaCl2 plus H2SO4. You get them? So you don't get barium chloride there. But now the issue here is that this barium chloride that is gotten, write down the barium chloride, comma, a white precipitate that is insoluble in HCl. So the barium chloride is insoluble in HCl. This is a test to know that sulfate is inside something. You get? Sulfate is inside an item. So we'll move to the next one. So barium sulfate, which will now give you, if you react with HCl, give you barium chloride, a white precipitate which is insoluble in dilute HCl. Number 9. When chlorine gas is passed into a solution of sulfur dioxide is SO2. You can write sulfur dioxide equals SO2. What will happen? Let's write an equation down. SO2 plus 2H2O plus Cl2 equals H2SO4 plus 2HCl. 2HCl. Next line, write Cl2 oxidizes SO2 to give you H2SO4 while itself is reduced to HCl. This statement you write now, very important. I want you to read it again like 3 times. Now let's go. They say when chlorine gas is passed into a solution of SO2, which is sulfur dioxide, what will happen? I already given the answer. Dilute sulfuric acid and hydrochloric acid are produced. H2SO4 and HCl will be produced. But just like you've written down, Cl2, which is chlorine gas, oxidizes SO2 to H2SO4 while itself will be reduced to HCl. Number 10. Run. Which of the following derivative of nitrogen affords an aqueous solution having a pH of less than 7? Which they're asking you now, which of these derivative of nitrogen is kind of acidic? Which of them is acidic? Don't forget, write down NO2 is an acidic gas or acidic anhydride. How do they spell anhydride? ANHYDRIDE, acid anhydride. Now write 2H2. Now write 2NO2 plus H2O would give you HNO2 plus HNO3. So NO2 is an acid anhydride. NO2. 10 is option C. You know hard. 11. The brown coloration in nitric acid prepared in the lab can be removed by, write down. Decomposition of nitric acid produces brown NO2. So you know say the color of NO2 now brown. So you could put it there. NO2 equals brown color. So like I said, decomposition of nitric acid gives you brown NO2. Next line, write HNO3, and they call nitric acid, equals 2H2O or equals H2O plus NO2 plus O2. That's like a chemical equation I just gave you now. Notice you get HNO3, which is the nitric acid. It has decomposed, meaning it don't break down. You can't give you H2O, you can't give you NO2, you can also give you O2. You feel them? Now, next line, right? This reaction can be reversed by bubbling air into the acid. So let's go back to 11. They say the brown coloration, once you hear brown for chemistry, just listen at NO2. In nitric acid prepared in the lab can be removed by, how do you now remove this brown color? Remember we said, bubble it. So you see, bubbling air through the acid. Once you bubble air through the acid, you go reverse the coloration. When they say can be removed, they means how can we reverse it? You know hard, it's simple. Number 12. Allotropes are elements having, right? Allotropes are elements that exhibit that exhibit different physical properties. So you could also write the physical properties is in different states, like allotropes of carbon. Now diamond and carbon. Diamond they get refractive index, is they shiny. Graphite na carbon. Your petroleum get a huge level of carbon inside of it. If you burn firewood, wood charcoal, if you charge sugar, how they charge sugar, you can try it now. You could pause this video, get a little bit of sugar. I know I asked you to do it, but you could try it. You put it in your pot. After some time, you see the sugar becomes gummy, becomes brown, and becomes black. You just char the sugar. That is also carbon. Do you get? So it's allotropes of carbon. Carbon exists. They are in the same physical state. They have the same physical properties, but they are existing in different physical states. That's what they call allotropy. So right, sulfur's allotropes are rhombic sulfur, monoclinic sulfur. These sulfurs are chemically the same, but exhibit different physical properties. That's what they call allotropes. Okay, so number 12, go back to number 12, right? Allotropes are elements having option A, different physical, but is different physical state, but the same chemical properties. 12 is option A. So carbon, sulfur, they exhibit allotropy. Even phosphorus, so right? Carbon, sulfur, and phosphorus. Yes, phosphorus. We'll go number 13. Which of the following states about phosphorus is not correct? Which of the following states about phosphorus is not correct? They say phosphorus exists in 2 allotropes. That's a lie. Right. Phosphorus exists in 3 allotropes. Phosphorus exists in 3 allotropes, but only 2 are more relevant. E.g. or i.e. red and white phosphorus. Yes, there's another one they call yellow phosphorus. But right, yellow phosphorus equals red phosphorus. So the main phosphorus we are having are red, white and black. Red, white and black. But you see this red and white might be the most relevant ones. So option B. 14. The product of the reaction between dilute sulfuric acid. Sulfuric acid is H2SO4, and sodium thiosulfate crystals are. I want us to write this chemical equation down. This one you need to know the chemical equation to pick the answer. Right. H2SO4 plus Na2S2O3 equals Na2SO4 plus H2O plus SO2 plus S. Next line, right. Na2S2O3 equals sodium thiosulfate. It's actually sodium thiosulfate 2 also. Yeah, sodium thiosulfate 2. So if you go back to question 14, they say which of them are the product. Don't forget, say you go get sodium sulfate, which is Na2. This one has sodium sulfate, Na2SO3. You get SO2, so this one no enter here. See, the correct answer is option C. Na2SO4, SO2, S, and water. Sometimes they'll put the water before the S, which is sulfur. No wahala, pick 'em. So 14 is option C. 15. When hydrogen sulfide and sulfur dioxide are each passed into a solution of potassium dichromate, hydrogen sulfide is H2S, sulfur dioxide is SO2. What will actually happen? 15. Right. H2S and SO2 are reducing agents. They are reducing agents. H2S and SO2 are reducing agents. They are reducing agents. Next line, right. Properties of reducing agent 1. Properties of reducing agent 1. They decolorize, acidify KMNO4 solution. They decolorize, acidify KMNO4 solution. Next line, you could also write. They change the orange color of acidified K2Cr2O7 solution to green. And in addition, H2S, which is hydrogen sulfide, would form a yellow deposit of sulfur. Let's come back to question 15. If you check all the options, you see option E is correct. Only hydrogen sulfide deposits sulfur. See, the both of them will do the same thing to KMNO4 and K2Cr2O7. But how do you separate one from another? Hydrogen sulfide will form a yellow deposit of sulfur. So hydrogen sulfide forms deposit of sulfur. 15 is E. 16. What happens when the nitrate of potassium, calcium, zinc, and copper are separately heated? You need to first know about nitrate. We talked about that in the previous chapter. What will happen is the nitrate of calcium, zinc, and copper, they decompose to their oxide. We've talked about this. We've given notes. You could go back and review the previous video. Chapter number 16 is option E. Right? Yeah. 17. When a solution of silver nitrate, similar thing again, is saturated with hydrogen sulfide. So silver nitrate, don't forget why I say the way they test for hydrogen sulfide though. You can use silver nitrate, you can use lead nitrate. So here, they say when a solution of silver nitrate is saturated with hydrogen sulfide, a black precipitate form, which is, they say silver nitrate oh, silver nitrate. Some people will go and pick option C. The answer is option B. Some students will pick option C, since the both of them can be used to test. But here they didn't say lead nitrate, they say silver nitrate. So what you get is silver sulfide, which is this one. 17 is option B, and it's actually a black precipitate. It's a black precipitate. So some students will go and pick silver. Some students will go and pick lead sulfide, but the answer they give you here is silver nitrate. Number 18. A piece of burning sulfur will continue to burn in a gas jar of oxygen to give a misty fumes which readily dissolve in water. See something? A piece of burning phosphorus. Alright, so let's continue. The question here is said a piece of burning sulfur would continue to burn in a gas jar of oxygen to give misty fumes which readily dissolve in water. The resulting liquid is, now let's write down, sulfur S plus O2 equals SO2, then plus H2O equals H2SO4. Okay, so what will happen is that it will give you trioxosulfate 4 acid, which is H2SO3. I would like to take the equation I gave again. S plus O2 equals SO2 plus H2O equals H2SO3. Now H2SO3 now they call trioxosulfate 4 acid. You understand? Good. Next line, right? When this happens, only SO3 would be formed. Only SO3 will be formed. But if the catalyst V2O5 is used as in contact process, H2SO4 will be gotten. Next, let me give you the equation now. SO2 plus O2 would give you SO3, right? Remember, I would say when you add water, you give you SO3. Check the previous equation I gave now. Then, if you add vanadium 5 oxide, which is V2O5, you will now get H2SO4. That's what they call contact process, which is the process that is used to produce H2SO4, the most popular acid also. Yeah. So let's go back. So number 18 said a piece of burning phosphorus, meaning if they say burning, they means phosphorus reacting with oxygen. Don't forget, it's simple. Will continue to burn in a gas jar of oxygen. You see, to give oxygen here, to give a misty fume. This misty fume is SO3, which readily dissolve in water. These misty fumes can dissolve in water, and if it dissolves in water, it gives you H2SO4. Don't forget. Sorry, if these misty fumes dissolve in water, it gives you the SO2. If it dissolves, it gives you SO3. Now, this SO3, if you bring the catalyst V2O5, you will now get H2SO4. So let's go back. So they say dissolve in water. The resulting liquid will be trioxosulfate 4 acid, which is H2SO3. Don't forget. 19. Which of the following method may be used to prepare triazonitrate 5 acid, nitric acid in the lab? So you need to know, how do you prepare nitric acid in the lab, right? The principle of using a strong acid, H2SO4, to displace a weak acid or a volatile acid from its salt is used. So let's go back to number 19. I will stop at question number 20 here. Which of the following method can be used to prepare triazonitrate 5 acid, which is triazonitrate 5 or nitric acid? 19. You see, you heat sodium triazonitrate 5. Sodium triazonitrate 5 is the salt of nitric acid with tetraoxosulfate 6 acid. Now, Sodium triisonitrate 5 is like much more of a weaker acid compared to H2SO4, which is a stronger acid. So you use the principle of using a stronger acid to displace the salt of a weaker acid. So to displace the acid from its salt, so 19 is option C. Let's touch the last question on this video. So we'll continue from the next video. 20. An element that can exist in two or more different structures form which possess the same chemical properties, allotropy. 20 is option E. No need to talk much about it. We'll stop here. In the next video, we'll continue from this place. If you've gotten to this place, I would like you to hope you've jotted down. If you are yet to jot down, go over, rewind this video and jot down the point. Snap and send to us on the WhatsApp group for assessment and also for correction. If there's any place you have a question, I'd like you to get to us on the WhatsApp group. How do you get to us on the WhatsApp group? I'm going to leave the link to the WhatsApp group in the description box. See you there. And lastly, be notified that we run daily classes. If you'd like to enroll in our class, you could reach out to us from the WhatsApp, from the description box of this video also. Thanks for watching. I'll see you in the next video.